Welcome engineers, Hassan here. Today we'll look a little closer at bit shift operations. Besides the banal multiplying or dividing numbers by a power of 2, what are some other practical use cases for bit shifts? Great question. Let's take a look at the example. Suppose you have a system where several server nodes write to a shared location. You need to uniquely identify each data row they produce, so we need to generate a globally unique key. Generating a unique local ID is easy, but a globally unique ID is a different story. There are several ways we can do that. We could have our servers negotiate with each other on key generation. This would be a fairly slow process since each node needs to notify every other node in the cluster about a new key it had issued and hope those other nodes didn't do the same in the meantime. There are ways to make it more or less efficient, but this approach doesn't scale well. The larger the system, the more negotiation has to be done and the more collisions we will get. Alternatively, we can use a separate key generation service that would be creating and distributing globally unique keys. Usually, KGS or key generation service creates unique keys locally and distributes them amongst nodes. Each node has a pool of keys it can use, and once the pool gets depleted, it requests more keys from KGS. This might be a good solution, many systems work like that, but this may be a little too complicated for many scenarios. What if we could have each server generate a globally unique ID on its own by using the local ID and node ID? A naive approach would be to just add node ID and local ID together. Let's see how this would work. Node 3 has a row with local ID 10 and wants to save it in the shared data storage. First, the server adds its node ID to the local ID. 10 plus 3 gives us 13. We save it in the data storage. Now we have the first node trying to save a row with ID 12. We add node ID to it. 12 plus 1 also gives us 13. Now we store it in shared data storage. We have created ourselves two different rows with the same ID. Not cool. An alternative approach would be to concatenate our numbers and use a hash function, but that could still give us a possibility of collisions. There is a simpler and more robust way to do that. We can designate the several bits of our number to the node ID and the rest for the local ID. The number of bits for each group should be determined by the number of servers we want to identify and the number of unique local IDs. In this example, we would use 4 bits for node ID and 12 bits for local ID. Now when we have a node 3 with a data row with local ID 10, we first set our 4 left bits with node ID and then set the rest bits with local ID. In code, it'll look like this. We take node ID, shift it 12 positions to the left, and then use OR operator to set right bits with local ID. Here is what this is going to look like. First, we have an empty block of memory, a bit set of zeros. We init it with node ID, shift it to the left, init a second bit set with local ID, perform the logical OR operation, and we are done. Now we have a globally unique ID. It may sound a little complicated, but really we just did one bit shift and one OR operation to solve a fairly complicated problem. Using a simple 64-bit number, designating the first 10 bits to node ID and leaving the rest 54 bits for local ID, we can cover a cluster of 1,000 machines given each 18 quadrillion unique keys. Simple technique that covers the vast majority of cases. That's been a quick example of how useful and practical bit shifts are. If you have any questions or comments, please leave them down below. Thank you for watching.